Hello viewer, you're watching Elim TV. Welcome to Form 1 Chemistry. This is our lesson number 2, Introduction to Chemistry, and we're going to look at chemistry laboratory and apparatus. I'm your teacher, Benjamin Makanda. So be with me. I want us to begin by looking at this photo over here. So make an observation of the photo you see here. What can you say about this photo? What does it represent? And what are you able to see in this structure here? There are glasses there. We have some containers carrying some substances inside there. Then we also have some equipments. So how can you call this kind of a setup? Maybe this is what we call a laboratory. Yes, indeed it is. This is a laboratory, and therefore, what's a laboratory? So a laboratory is defined as a special room where practical subjects such as chemistry are studied. The equipment used in the laboratory, we call them apparatus. So those equipment that we use in the lab, we call them apparatus. Now, if we refer to our photo here, those equipment that you are able to see are our apparatus that we use in the lab for carrying out the practicals. So the building or the setup is a lab, and it's a special room where practical subjects are being done, or we study practical subjects from there. And then the equipments that we found in the lab, we call them apparatus. That's the first aspect of what we're supposed to discuss. Moving on, we look at chemistry and laboratory apparatus. And in the lab, we have said those equipments grouped there are called apparatus. Some of the apparatus in the laboratory are used as follows. So we can use this apparatus as 1. Sources of heat. They are used for heating. We can also use the apparatus in the lab as a means of measurement of volume. The apparatus can also be used in the lab in measurement of temperature. We can also use them in measurement of mass. We also use this apparatus in the lab in measurement of time. So these are some of the uses, or how these apparatus are used in the lab. We use them as sources of heat to measure volumes. We can also use them to measure temperature, masses of objects, and time. Now, let's look at sources of heat. What are some of the sources of heat in a laboratory, given that it is a special room where practicals are being done from? These are some of the sources of heat. The pieces of apparatus used as a source of heat include: 1, we have a Bunsen burner. We also have spirit lamp being used in the lab. We can also have candles. We also have gas stove, which are also known as portable burners because you can carry them from one point to the other. We also use kerosene stove as sources of heat in the lab. We use electric heaters. These are some of the apparatus that are used in the lab to provide heating. You know, most of the practicals in the lab, they may require some heating. So these are some of the apparatus that we're likely to use. Now we are going to look at the first apparatus there, which is a Bunsen burner. And what is a Bunsen burner? Now here we have one of the source of heat from the photo here. One of the source of heat. And this one is our Bunsen burner. You can see some flame there. So this is one of the sources that we use in the lab to heat various experiments that are being conducted in the lab. Now, we begin by looking at the Bunsen burner as one of the sources of heat in the lab. And what's a Bunsen burner? Let's look at something, some history about a Bunsen burner here, It is the most commonly used heating apparatus in the chemistry laboratory. And it was invented in 1854 by a German chemist called Robert Wilhelm Bunsen. That's in the year 1811 to 1899. So this source of heat in the lab is actually a very old source of heat, invented in the 18th and by a chemist scientist called Robert Bunsen. Now the word Bunsen burner, Bunsen is the name of the inventor of this apparatus, meaning that it has been there since time immemorial, and it's still being used up to this point as we speak. Now let's look at this apparatus, or this source of heat, a Bunsen burner. Now this is a picture photo of a Bunsen burner used in the lab. So that's what we have. We are going to look at the various parts of this Bunsen burner and how they are being used to produce heat. That's all about the Bunsen burner, but we have this other information about it. Parts of Bunsen burner. So what are some of the main parts of the Bunsen burner? So a Bunsen burner consists of three major parts. The first part is the collar. Any Bunsen burner will have a collar. So the other part of a Bunsen burner is called a chimney, and in some cases we call it a barrel instead of a chimney. It's a chimney or a barrel. It's another part of a Bunsen burner. The other part of a Bunsen burner is the base. The base. A Bunsen burner therefore has three parts: the collar, the chimney, and the base. Now, this is a photo of the Bunsen burner, an ideal Bunsen burner. Now, that upper part is named as a barrel. The barrel of a Bunsen burner is also known as a chimney. Then we have the collar. This collar is connected to the source of heat. That is actually the gas that burns. So we have an air hole there, which actually connects the gas that burns in the Bunsen burner and the air. That's where we have the mixing of the gases taking place. Then we have the gas jet and the base. The base provides support for the Bunsen burner so that the Bunsen burner is stable, it does not topple very easily, and is able to be supported. So those are the three parts of the Bunsen burner. Moving on, let's look at now the specific parts of this Bunsen burner. And we have this one here. Which part is this? Having looked at the skeleton of a Bunsen burner, are you able to identify this part of a Bunsen burner? Yeah? Which part is this? I know you have identified this part as the collar. This is the collar of a Bunsen burner. So this part here that has an arrow is the collar of the Bunsen burner. Now, what can we say about the collar of the Bunsen burner? It is a metal with an air hole whose diameter is the same size as that of the hole in the chimney. So that is all about the collar. It's just a ring with an air hole. The role of this air hole is to provide air in the Bunsen burner so that this air can mix with the laboratory gas and they burn to produce flame. So it contains an air hole which provides air that mixes with the lab gas. And then the diameter of the collar is almost the same to that one of the chimney as we're going to see. The reason behind this is so that the two can fit in properly, so that we don't have another space. Then another thing that we can say about the collar is that the diameter of the collar is slightly bigger than that of the chimney, so that the chimney can just fit into it. So they are actually compatible. Once they fit into one another, they are able actually to work without any problem. So the diameter of the collar should be slightly bigger than that of the chimney so that they can fit in one another. So that part there is the first part, and we have identified the part as the collar of a Bunsen burner. Now moving on, what about this one here? Are you able to identify that part of a Bunsen burner? From the overview of the Bunsen burner, which part is this? Do you identify this as a chimney? Then you are right. This is the chimney of a Bunsen burner. And what's the chimney? It's a hollow metallic cylinder with an air hole near its lower end. So from this one, this one is a barrel, which is also called a chimney. It has an air hole that is near the lower end. And the role of that air hole, as you have seen with the collar, is to provide air that mixes with the gas that burns. So this air hole must actually fit in the air hole on the collar for the provision of the gas to be effective, so that heating or combustion can be able to take place in the Bunsen burner. So the third part of a Bunsen burner is this one here. Are you able to identify this part? So of course, this is the last part, and this part is called the base of a Bunsen burner. So what about this part? This part is made of thick metallic material into which a small hollow metal with a jet is fitted. So actually the base of a Bunsen burner provides the support to the Bunsen burner so that we have some kind of stability. So when the burner is burning, the burner does not actually topple easily. Now let's look at how these parts work in a Bunsen burner. So we have a summary of how these parts of the Bunsen burner works here. The first part of a Bunsen burner, we said, is the collar, and it is used to regulate the amount of air entering the chimney. So the collar regulates the amount of air that gets into the chimney. How does the collar regulate the amount of air getting into the chimney? It contains an air hole which can be adjusted to any size so that it allows a given amount of air to get into the Bunsen burner for combustion to take place. So that when you reduce the size of the air hole, the amount of air getting to the Bunsen burner becomes less, and then combustion is incomplete. So the heat produced in the event is less than a case where the air hole is left wide open, where a large amount of air gets into the Bunsen burner, providing maximum or complete combustion, which actually provides intensive heating. So that's how it regulates the amount of air entering the chimney, by adjusting the size of the air hole on it. Then the other part is the chimney, which is also known as a barrel. The barrel contains an air hole in the chimney that allows air to enter and mix with the laboratory gas from the chimney. Just like the collar, it also has an air hole that allows air to get in and mix with the laboratory gas from the chimney. The lab gas from the chimney therefore mix with the air, and then when it is ignited, it burns, and that burning is what we call combustion, which leads to the production of heat. That heat that we're able to see, we're going to identify it as a flame, because the two mixtures burn to give us a product that has some heat, which is a flame. Then the other part is the rubber tubing. Now, I want to relate this Bunsen burner to some of the heating apparatus you use at home. The commonly used apparatus at home, which you may be having at home, even in your lab, in the lab in your school, is a gas cylinder. So we have this tall gas cylinder of about 13 kilograms. How do you connect it from the source to the burner? You use a rubber pipe. That rubber pipe is what we call the rubber tubing to connect the gas and the burner. So the rubber tubing conveys burning or the gas from the cylinder or the source of the gas to the burner, so that combustion can be able to take place. So same applies to the Bunsen burner. It connects the gas inlet to an external source of laboratory gas, so that we have combustion taking place, which leads to the production of heat. So we now want to look at what is being produced when the lab gas is mixed with air. What is formed? Look at my photo here. Are you able to read? Inside you will get the word flame, future for language as a medium of education. Yeah. Now, what symbol does this one represent? What's the color of the flame produced by a candle, a kerosene lamp, any other source of heat? Does it resemble this one here that you are seeing here? Maybe to some extent they resemble. And therefore now, the key word here we are looking at is the heat that is produced from the various sources of heat produce this product. And the product we want to talk about in this case is the flame. Therefore, what is a flame? So this one is a flame. So how do we define a flame? A flame is defined as a mass of burning gases. Mass of burning gases. So I want us to digest the definition. Mass of burning gases, meaning that the gases that are burning, they are actually in large quantities, but these ones are mixtures. So when you burn large quantities of gases, they give you a product called a flame. So going to our Bunsen burner, if you mix laboratory gas and air, then they form a mass of burning a mass. When this mass is burned, it produces this kind of a flame. So a flame is defined as a mass of burning gases, meaning that when the gases are burnt, they produce what? They produce flame. Are you able to identify types of gases that mix with the air to burn and give us flame? Maybe at a later stage, we'll have gases like methane, we have ethane, butane, they mix with the air, and in air we have oxygen, then ignited to produce what? To produce a flame, which we are seeing here. So it's right to say that a flame is a mass of burning gas. Now, still on the flames, when in use, a Bunsen burner produces two types of flames. depending on amount of air allowed in the chimney. You realize that a Bunsen burner has an air hole that regulates the amount of air getting into the chimney to mix with the laboratory gas so that combustion can be able to take place. Now, depending on how you deal with the air hole will give you a specific type of a flame being used there. Now, these two types of flames are, as we are able to see here, types of flames in the lab produced by a Bunsen burner. We have one known as non-luminous flame and the other one is known as luminous flame. These are the two types of flames produced by a Bunsen burner, non-luminous flame and luminous flame. So we want to look at the individual flames and how they are produced by a Bunsen burner. And as I said, these flames are produced on the basis of the adjustment of the air hole. How you adjust the air hole will determine the kind of a flame that you produce. And just before we go to the details of these flames, now I want you to make a comparison between an open fire and the flame from maybe a gas or a candle. Do they look alike? What is the intensity of heat produced by the two flames? The one that is produced by a gas, a candle, and an open fire? Definitely you may be having different answers for the same. So now let's look at these flames. We begin by looking at luminous flame. What's a luminous flame? This is a flame produced when the air hole is closed. When you close an air hole, then the flame produced is known as a luminous flame. The air hole is closed, and therefore the amount of heat getting into the system for combustion to take place is also minimized, meaning that for this flame to be produced, incomplete combustion takes place. Another thing about luminous flame that we should be able to recall is that the flame produced is bright yellow and large. Bright yellow and large. If you have a candle, or you may be able to conduct this experiment later on and make your observations, you light a candle, look at the color of the flame and the intensity of light. If it is bright and yellow and the flame is large in size, then that flame is a luminous flame. That's another thing we have to note about luminous flame. The other thing about this flame, that it gives out much light. This flame gives out much light, and therefore the flame is suitable for lighting purposes. We can only use this flame to give us light, but we cannot use this flame to give us what? To heat apparatus, because the amount of heat produced by this flame is not enough to heat in the lab. Now, looking at the color of the flame is not uniform, and 4 zones can be seen from luminous flame because the color is not uniform. So 4 zones are seen on the luminous flame. So these 4 zones can be named starting from the bottom of the flame, and at the bottom of the flame we have unburnt gases. So that zone is somehow dark because we have incomplete combustion. And remember, it is the gases that are burning. So when the gases burn, they burn in limited supply of oxygen. Then incomplete combustion takes place. And when incomplete combustion takes place, gases are members of a group of compounds called hydrocarbons. Hydro is hydrogen, and then carbon is carbon. Therefore, when you burn a gas, what do you have? You have hydrogen and carbon burning in oxygen to give us what? Carbon dioxide and water. Therefore, that carbon, if it is not burned properly, you will be able to see some dark substances. Those dark substances represent carbon that are unburnt. That's why this flame at the bottom is dark, because the carbon particles in the gas have undergone incomplete combustion. They have not been burnt properly. The second zone is a blue in color. It's the blue zone of partial combustion. Here combustion takes place partially because to some extent the supply of air here has improved, and therefore bit of complete combustion takes place here. Then we have the middle part, which is almost colorless because we have complete combustion taking place here. All the carbon and hydrogen within the gases, they are burning because of the full supply, large supply of oxygen gas, therefore complete combustion is taking place at this zone, and therefore giving the zone a colorless, the zone becomes colorless for that matter. Then the last part of the flame is orange, and sometimes we call it the yellow zone of the flame. The yellow zone of the flame has also incomplete combustion, because the remaining carbon particles now have to be burned here. And remember now, this is the exiting point of the flame, and therefore we have here incomplete combustion taking place on this flame. That is about luminous flame. But still on the same flame, the flame has 4 zones, as we have seen. The first zone is the blue region. So this flame has the blue region. So the other region of the flame is the almost colorless region, which is in the middle of the flame. We also have the luminous bright yellow region. Luminous bright yellow region. I would like us to understand what the word luminous means. Luminous means presence of light. So when someone tells you these are luminous objects, these are the objects that produce light. For example of luminous objects are sun, candle, etc. Now, this flame has a luminous zone, luminous bright yellow region, meaning that this region produces a lot of light, and this one is related to the fact that some of the unburned carbon particles, they glow red hot. The carbon particles that have undergone incomplete combustion, they are glow red hot, and in the process, they produce what? They produce light. So this region becomes a luminous bright yellow region, which gives this flame, it is used as a source of light. Now, the last one is a thin outer region. This region is not easy to see because it's very thin. It may actually be, when you are observing the flame, you may not be able to notice the existence of this region. It's very thin unless you use an aided equipment to help you. So from there, we now have a summary of these regions of the luminous flame. The first one is the blue region. It occurs at the bottom of the flame. Air near the flame rises rapidly and mixes with the burning gases. Then the other one is the almost colorless region. This region consists mainly unburnt gases. Those are the 2. Then we go to the other 2. We have luminous bright yellow, and you see from our presentation we also have that region as yellow. The region is yellow because we have used the yellow color because the region is luminous bright yellow. Consists of unburnt tiny particles of white hot solid carbon which give out light because they glow. The unburnt carbon particles produce the black soot which makes the apparatus dirty during heating, and therefore this flame is not suitable for heating because it makes the apparatus dirty because a lot of soot is produced. The air supply in this region is limited, and hence there is incomplete combustion of the gas at the luminous bright yellow region. What of the thin outer region? This is what we have to say. The gas burns completely because it mixes with plenty of air. This region is normally difficult to see. You may not be able to see this region because it's very, very thin. Now, non-luminous flame. This flame is produced when the air hole is open, opposite of the luminous flame. The other thing that we have to note about this flame is that the flame produced is blue in color. What's the color of luminous flame? If you can recall. Yeah, is bright yellow flame. You can also call it luminous bright yellow flame. So the non-luminous flame is blue in color. And look at the color of the flame produced when a gas is burning. Maybe the gas that you use for cooking at home, the flame is blue. So that one is an non-luminous flame because the switching on of the tap opens the air hole to supply air. So that one's an non-luminous flame. The non-luminous flame has 3 regions, unlike luminous flame which has 4 regions. So this is the diagram representing the non-luminous flame. Beginning from the bottom of the flame, we have the dark zone of unburnt gases. These gases undergo incomplete burning because of limited supply of oxygen. The middle part contains blue zone of partial combustion because the air supply has improved here. Then the hottest part of non-luminous flame is the outer region, which is almost colorless zone of complete combustion. We will be able to carry out the experiment to ascertain the hottest part of a non-luminous flame, and we'll actually establish that outermost region, the one that's the most hottest part of the luminous flame. So still on non-luminous flame, we now summarize the parts as follows. So non-luminous flame has these parts, almost colorless region. So in this box, that white in science means that there's no color. White is not a color, therefore it's almost colorless region in science. Then we have greenish blue region. So we have used the word green there because we have a region that is green in this flame, and a pale blue region. You should be able to identify whether that color is pale, so that in the next lesson, try to contribute to that color. So those are the parts of non-luminous flame. There are 3. So still on this flame, so we can now summarize as follows. Almost colorless region. This region consists of unburnt gases. Why? Because the air supply is limited. So the gases undergoes incomplete combustion. What of greenish blue region? It is in the middle of the flame. It contains partial burnt gases due to insufficient supply of air. Then the last part of this flame is pale blue region. The gases burn completely because there is plenty of air. A lot of air is supplied here, therefore the combustion is complete. The outcome, the resultant flame is blue in color. Now let's compare the 2 flames, luminous and non-luminous flame. So what's the comparison between the 2 flames? What can make you differentiate between a luminous flame and a non-luminous flame? Do you have this with you? Luminous flame has 4 zones, and you have seen that. What of non-luminous flame? Yeah, it has 3 zones. We have discussed that. The other difference between the 2 flames is that a luminous flame produces a lot of light. Non-luminous flame produces a lot of heat. Luminous flame produces a lot of light. Non-luminous flame produces a lot of heat. Then the other difference between the 2 flames is that luminous flame produces soot. What of non-luminous flame? Does not produce soot. So if you take, you light a candle and then just hold your hand above the candle, then after some time you will realize that some black substance is getting onto your hand. And then you can also do the same with the flame that is from a burning gas, maybe a gas used for cooking and all that. Just above the flame carefully, you realize that your hands will not be made dirty. This is because the gas produces a luminous flame that does not produce soot, while the candle will produce a lot of soot. So the other difference between this flame is that the luminous flame burns quietly. It burns quietly, it doesn't burn with a lot of noise. And this one, I think you can be able to do it at home. Is your takeaway assignment. Go and listen to the 2 flames produced, whether luminous or non-luminous. Which one produces a lot of noise and which one is a quiet flame. That quiet flame is a luminous flame. And then non-luminous flame burns. It burns with the roaring noise. Look at an open fire. When you burn open fire, you burn papers and all that. A lot of noise comes from it because it's an non-luminous flame. Now the other one is luminous flame is fairly hot. It's fairly hot, and we said it's not used for heating. It's used for producing light. And then this other flame is very hot. Before we summarize, you will carry this homework so that when we meet, I will look at the homework. You will give me the feedback. Look at your homework before we proceed to our second lesson. Now, this is the work that you have to do. What do you call the flame produced when the air hole is open? From the discussion, I hope you are able to identify that flame that is produced when the air hole is open. The other thing you will do, explain briefly why the luminous flame produces light while the non-luminous flame does not. These are the 2 questions that you attempt, and I can get your feedback through the number 40007. You can also use our Facebook page so that we get your feedback, the questions, the comments, and any other contribution you wish to have. So up to there. Thank you very much. Until next time, stay tuned to LMTV. I've been your teacher, Makanda Benjamin.